Hey everybody. I've been asked for a lot of specification on 5.1 and talking specifically about the bonding question that I had posted between sodium and chloride and how these two things come together from just being atoms and then transferring into ions and then transferring into an ionic compound from there. So I'm going to run through this and I'm going to do a different example than the sodium and chlorine. I'm going to use for this one, let's say lithium and fluorine. Now, you can just kind of imagine these, right, as atoms that are just floating around, and until they get to a certain distance from each other, nothing is going to happen to them. Now I'm going to put and I know that we don't draw our atoms like this, but I'm going to put the valence electrons on the outside. 1, 2, 3, 4, 5, 6, 7, just to kind of show what's going on with relative distance. If you look at the periodic table, right, both of these, lithium and fluorine, are in the second energy level. So we're going to have 2 rings of electrons here. Let's see. Oh, this is the wrong tab. Alright, so 2 rings of electrons for each. So these are the same kind of relative distance. And what happens is eventually, these atoms might get a little bit closer to one another. When that happens, let's say we're kind of blowing up this view here, right to the inside of the nucleus, and there are many more positive charges in fluorine than there are in lithium, right? Lithium has 3 protons. Fluorine has 9. So what that means is negative charges, and in particular what we're talking about right now are these electrons, right, that we have orbiting each atom. It's kind of a nasty color. I'm going to switch that to green here, make it easier to see. So the electrons are going to be more attracted to fluorine because it has more positive charges, and we're talking Coulombic attraction, right? This is the same distance but increased number of charges. So there's going to be more attraction to the one that has significantly more charges. It's 3 times the amount of charge. Another way you can know that is to look on our periodic tables. There's this table called electronegativity on the back side of the periodic table that you have in class, and that I've posted here on Google Classroom as well. So if we look at lithium has an electronegativity of 1, and fluorine has an electronegativity of 4. Now, electronegativity isn't something that we really talked about, so let's discuss what those numbers mean. Electronegativity is essentially the degree of attraction that these elements have to other negative charges. So the higher your electronegativity value, 1 on lithium, 4 on fluorine, the more attractive electrons will be to that atom's nucleus. So fluorine is 4.0, lithium is 1.0. Fluorine is actually, mathematically speaking, 4 times more attractive to an electron than lithium is. So if there was a fight, in ownership of an electron between these two elements, it's always going to go to lithium or to fluorine, because fluorine has higher electronegativity because it has more protons, more attraction to that electron. So now I'm going to get rid of our blown up views here. And actually we can get rid of this too. We don't need it anymore. We're going to switch over to Lewis dot structures. Alright, so let's say, just like I have up here, okay, these atoms get close enough to each other that they can feel attraction from one another. Lithium, in that single electron, lithium is going to lose that electron to fluorine. Why? Because fluorine is so much more attractive, right? It's got 9 protons compared to lithium's 3. And if we look on the periodic table again, it has so much more electronegativity. So we transition over from atoms to ions. Because of that electronegativity, right, that attraction to the nucleus, fluorine gains that electron, which then puts charges on the two of these. Lithium is now positive charge for having lost an electron. Fluorine, and now a fluoride ion, is possessive of a negative charge because it has gained an electron. What happens there is, again, these were close enough to each other, right, that this electron could transition over, but that in itself doesn't form a bond. There's nothing special about an electron transitioning that forms a bond, right? These are not connected at all. Lithium is its own ion. Fluoride is its own ion. What happens is that we still have mutual attraction to each other in the form of these full-on charges, right? Lithium having a positive charge, fluorine and fluoride ion having a negative charge. So this means that they are attracted to one another due to our opposition of charges and Coulombic attraction here. So they will together form a compound when they come together, right? Like lithium fluoride. And this is true of any positive and negative ions. The positive ion will always have a lower electronegativity than the negative ion. And so the positive ion loses, or that what will eventually become the positive ion loses its electron over to what will eventually become the negative ion, and then they proceed from there. Mutual attraction, and it becomes a compound. So I hope that answers a lot of questions. That was a pretty in-depth analysis, and I will see you for the next video.